So let's re-emphasize a few points on the future of CO2 and what's it doing? Okay, I'm trying to get the pointer up. So here we are again going from the industrial revolution, beginning of the industrial revolution to 2100. This is again from the previous projection. It's always hard when you are in the transition where new projection is still coming out and old projection is still the most dominant discussion that goes on. So we had representative concentration pathways defined as RCP 2.6, 4.5, 6 and 8.5. They correspond to the additional radiative forcing, not temperature. So 2.6 watts per meter squared, 4.5 watts per meter squared, 8.5 watts per meter squared additional forcing, and business as usual is always the top one. So here CMI 5 of course is the coupled model intercomparison project where you're using either an Earth system model or a physical climate model or a climate model with some chemistry but not necessarily fully dynamic vegetation and so on and so forth. And then there are other models called integrated assessment models, which include details of various socioeconomic activities, energy, transportation, agriculture, etc. And they tend to either put in the climate from a climate model, or they use some simple relations between temperature and economy, crop yields, and so on and so forth. So I won't go into the details, but to develop these scenarios, whether it's RCP 8.5 or shared socioeconomic pathways that we discussed and we will look at again, they are often done with the iteration between integrated assessment models and CMI 5 models, because CMI 5 models will give you more accurate evolution of the carbon cycle into the future, and that can be then fed into the integrated assessments to look at how temperature, precipitation and CO2 would affect socioeconomic activities and choices on energy and so on, and then feed that back to the climate model to produce the new evolution of carbon cycle and so on and so forth. So you get a sense here that we have been on this ramp up of CO2. As I said before, negotiations haven't made a dent yet, but we know that electric vehicles, renewables and so on are picking up, corporations are doing their own things, etc. So you can see here the range of scenarios from different models of coupled model and integrated assessment models for the various the RCPs, and this is in petagram carbon per year. So you can see that we would be, again, remember, going from petagram carbon to CO2 takes a multiplication of 3.73 or so, just make sure. So always be sure what you are looking at, carbon or carbon dioxide or CO2 equivalent, which is even further. Okay, so global surface temperature change associated with those RCPs is shown here. So the historical simulations and consistency with observed temperature change always gives us confidence, as we said, and then you project forward different number of models involved, different number of scenarios being simulated by each, and there is a range of confidence around the multi-model mean and so on. So RCP 8.5 would give us warming that simply is too catastrophic, and then the question is, how do we bring it down? RCP 2.6 is kind of safest one we can imagine to stay below 2 degrees C warming by 2100 with a 67% probability. This is going again out to 2300. So as I said, there are two questions. What is the uncertainty here? As we said before, in the early decades the uncertainty mostly comes from the models that we talked about before, and the uncertainty to outer longer terms, outer decades, mostly comes from scenario assumptions. But nonetheless, the other question is, what do we do with this information out to 2100? Okay, nonetheless, it's important to look at these. So here is a good example of how the projection looks for the last 2 decades of this 21st century from RCP 8.5. You expect polar amplification to be pretty massive by then because it's already here and quite large. So this is going in the range of 10 to 12 degrees, which would take us back to almost 65 million years in terms of temperature levels and CO2 levels when the dinosaurs were wandering around the planet. Then why do we worry about it if this has happened before? Of course, because we were not around at the time. So if the Greenland glaciers, sea ice and Antarctic glaciers disappear, sea level would rise by over 120 meters or so. So that also has to be considered. So you can see polar amplification, massive warming on all the continents, especially the global south. And the oceans would warm a lot as well, with amazing really catastrophic effects on ecosystems, ocean's ability to take up heat and acidification and other things. And the warm tropics probably wouldn't be able to deal with these changes. Plus there is additional constraints that with this kind of warming, the humidity would increase so much that the wet bulb temperature drops, which means the ability of the human body to lose or respond to the heat by sweating would be limited, and the number of deaths with heat waves would just skyrocket. Okay, so those are the kind of dangers we have to worry about. And of course, if you remember now your basic circulation of Hadley cell, Ferrel cell, Walker cell, everything, those would change as well, because you are changing the equator to pole temperature gradient. So the amount of energy that has to be moved would change. Distribution of rainfall and also would change along with the Hadley cell and so on. So this is showing for RCP 8.5 the zonally average temperature changes for the 20th century, 21st century in the atmosphere. So the warming would penetrate pretty high up into the atmosphere, raise the tropopause quite seriously, as you can see here, and the warming would go clearly into the stratosphere. This is in hectopascals, but tropopause ends around here, so you can see it would be raised by several kilometers, which is already happening. And you would make changes in the tropopause all the way across the globe as well. And here you are looking at pressure. So this is the ocean as a function of latitude and pressure. So in the ocean, the pressure increases as you go deeper. Here it decreases as you go higher. So you can see that the ocean heating would penetrate quite deep as well, with massive warming near the surface, even when we look at zonal mean. And because of the meridional overturning circulation, you have some patterns of warming and cooling that have to be taken care as well. Just to close this podcast, for changes in hydrologic cycle, as we said, precipitation is very difficult in terms of modeling and predicting and projecting. Nonetheless, you can see the stippled regions where there is high confidence from multiple models. Is a consensus answer from multi-models the right answer? Not always, but nonetheless it tells us that almost all models are saying similar things. So you can see that the subtropical gyres and deserts would get drier, and rainfall would increase tremendously over some regions, monsoon for example, and the ITCZ. So the question, as we said before, is whether ITCZ would move, would it get broader, would it get thinner, how the rainfall would increase in terms of intensity, duration, frequency and so on, and how the high latitude precipitation change would come, let's say over Greenland. Would it be more rain instead of snow, in which case obviously will drive the melting of glaciers, and you can see here it's getting drier, the precipitation is slightly higher and relative humidity is getting lower in the polar regions here in both sides, and there are complex patterns regions here, especially in the Sahel region, which is very sensitive in terms of poverty, boundary between deserts and semi-arid to wet regions. Amazonia looks pretty bad here. So if Amazon collapses, we would be in serious trouble. So later on we will look at some projections on tipping points in the Earth system. So there are the evaporation changes. There is the E minus P. So this is what is more important, which regions will get drier and which regions will get wetter. So E minus P positive means precipitation is getting less, evaporation is increasing but not enough, so they are donating moisture to regions that may be already wet. Soil moisture is also very difficult variable to measure, model, map, predict, project, and so on. Nonetheless, there are consistencies between E minus P, P, relative humidity, and soil moisture. We will see later on that the feedbacks become very critical. Where are there feedbacks that damp the effects of climate change, and where are there feedbacks that will amplify the effects of global warming? Those are the things we have to worry about. We'll come back and look at sea level rise, glacier melt, and other things in the coming podcasts. Okay.